So, good afternoon and welcome to today's second session. And this session is basically on Indian space program. This session was supposed to be delivered by Director Bikram Sarabhai Space Center, PSSC, Dr. Unnikrishnan Nairji, but due to some other engagement, he is not able to deliver this session at this moment. He will take his session tomorrow, 11 o'clock. But I'll be taking the first part of this session called as Space in India. So my name is Dr. Harish Karnatak. I'm a scientist and also head of department at Indian Institute of Remote Sensing, ISRO, Dehradun. So today in this particular session, I'll be discussing about how the journey of Indian space program was started and which are the important centers of ISRO and their activities, and how the Department of Space is functioning in our country, and what are our mandates, and what kind of technologies we are developing, what kind of applications we are developing. So I'll be giving you a brief idea about it. In continuation of this lecture, tomorrow morning, Director Bikram Sarabhai Space Center, Dr. Unnikrishnan Nairji, will be delivering the next part of this particular topic, that is on Indian space program. So now let us try to understand how the birth of ISRO happened. So how the journey was started. Although you will be getting a lot of literature in internet or libraries about the beginning of ISRO, but quickly I will tell you the foundation of ISRO was led by Dr. Bikram Sarabhai, who is known as a father of Indian space program. Dr. Sarabhai has set up a laboratory in his own private property in Ahmedabad, and this laboratory was known as Physical Research Laboratory. In fact, this lab is still available, it still exists, and this is one of the important leading research center of ISRO in Ahmedabad. And Dr. Sarabhai has started the Indian space research activity in the country from this place called as a PRL, Ahmedabad. If you see the foundation of this department, how it happens, basically, as I told you, that Dr. Sarabhai is known as the father of Indian space program, but actually Dr. Bhabha, Homi Jahangir Bhabha, Dr. C.V. Raman, Dr. Shanti Swarup Bhatnagar, they were the leading scientists and working together very closely to start the science activity in the country immediately after the independence. Dr. Sarabhai and Dr. Bhabha was looking for a place, a suitable place in the country from where they can start the Indian space program. They are looking for a very a safe place from where they can start launching of the program and all. But when the program was started in the country, initially it was set up as a committee for space research. It was known as Indian National Committee for Space Research, or we call it INCOSPAR. It happened sometime in 1962. So you can think that the country, our independence happened in 1947, but within very short duration of time, so around within 15 years, so we could start our program or Indian space program. That was a very, very big thing, because that time the science and technology may not be that much on priority of the government, but still government was convinced on the development of the space program in the country. And the later stage, this department was full-fledged developed as the Indian Space Research Organization, or ISRO, in 1969. So our journey started from INCOSPAR in 1962, and then in 1969 it became ISRO. So as I told you, the architect of the Indian Atomic Energy Program, Dr. Homi J. Bhabha, together with Dr. Sarabhai, were scouting for a suitable location to establish the India's first rocket launching station. And they are looking for a site which should be isolated near to the sea and close to the magnetic equator. So magnetic equator is very, very important, because initially when they start building this program, their focus was to build a experiment for the atmospheric and space research. So magnetic equators plays a very, very important role for such kind of experiments due to this electrojet near to a magnetic equator. So when they were searching for this place, they could locate a place called Thumba near Thiruvananthapuram. It's a village, very small place. There was a church called Saint Mary Church, and they basically approached the father of the church, and they briefed to him that they would like to take up this particular place for their scientific experiment, especially related to space. And this was a perfect suitable place for such experiment, and it was selected to start the space activity in the country. You can see a few of the visuals how it was started. It was very humble beginning. So when you must have seen so many pictures, photographs in internet also, you can search for that. So right from these small photograph to our a very advanced space data centers which is available in the country today. So the journey is a very long journey with a remarkable achievements. Now if you start from the first Indian satellite, which was basically known as the Aryabhatta satellite. This is a model shown here. It was launched on April 1975 with the help of USSR, so Soviet Union. So we launched this satellite. It was a first satellite which was launched by department in 1975, and the launcher, which was the first launcher of India, is called Satellite Launch Vehicle 3, SLV-3. You may be knowing that Dr. APJ Abdul Kalam was the project director of this launch vehicle. So Dr. Unnikrishnan Nair ji will be talking more about all these achievements in detail tomorrow. But if you see the first rocket when India has built is known as a Rohini rocket, Rohini 75, or we call it the RS-75. It was a sounding rocket. First time it was launched through our launching pad in Thumba, which is basically suitable for such sounding experiments. And today also still from these places we are still launching many sounding rocket for scientific studies. But we have the other operational launch vehicles like from SLV-3. The journey started from SLV-3. Now it became this PSLV, and then GSLV, GSLV Mark 3, and now ISRO is working on the reusable launch vehicle project as well. Now if you see the objective and programs of ISRO today, basically our objective is civilian use of space technology. So how we can use the space technology for civilian applications, and today we have the self-reliance, and India is fully capable of running of its own space program, and we have many advantages of space programs. Is basically we provide the timely information for many thematic applications like from farmers to fishermen and other common citizen services. So basically the civilian applications are based on the Indian space program today. And if you see how the complete organization is working in the country, so the Department of Space is coming under Prime Minister Office. We call it a PMO, and this is guided by a very high level commission called Space Commission. So here the eminent the space scientists and scientists from other discipline, and also the top administrators and the bureaucrats are the member of the Space Commission. And generally the Space Commission is chaired by Secretary Department of Space, which is also known as Chairman ISRO. So currently Dr. S. Somnath is the chairman of the Space Commission, and the Space Commission is guiding Department of Space for the different space program. And recently Government of India has also started basically to invite the private entities to participate in the space activity in the country. So for the regularizations and authorization purpose, recently in 2020 government has set up a commission called a separate body called InSpace, is the authorization board basically to connect the private entity with Department of Space for the commercialization of the space activity in the country. We also have a company called NSIL. This is a New Space India Limited. This is a commercial arm of Department of Space, They are responsible to basically commercialize the space technology and its applications for the national and international users. So this is one part of the story. Second, we have the autonomous laboratories or organizations, like as I discussed in the beginning, Physical Research Laboratory. They are basically located in Ahmedabad, responsible for the planetary experiment or scientific experiment related to planetary missions. We have the another lab called NARL, National the Atmospheric Research Laboratory. We have the Northeastern Space Application Center in Shillong and Indian Institute of Space Science and Technology IST in the Thiruvananthapuram. So these are the autonomous organizations. I will be discussing a little bit more about these laboratories and institutions in coming slide, what kind of activities they are doing, what exactly they are doing. Then we have the one virtual unit called ISRO, Indian Space Research Organization, which comes under Department of Space. Under ISRO, we have many centers and unit. So here centers are highlighted with red color boundaries, like a Bikram Sarabhai Space Center. We have the Liquid Propulsion Centers. We have the Satish Dhawan Space Centers. We have the U.R. Rao Satellite Centers, National Remote Sensing Center, Space Application Center, and down with the this blue borders, the units are highlighted, like we have the IPRC, ISU, STRAC, IIRS here in Dehradun, LEOS, MCR, DECU. Now DECU is merged with Space Application Center. So in coming slide, I will be discussing more about the activities of these ISRO centers and unit, what exactly they are doing and how we are building the Indian space program. If you see the dimension of the Indian space program, these are the major 5 dimensions on which ISRO is working. One is called space transportation. So ISRO is very seriously working on the space transportation component, and you are already aware of it. So we have the launch vehicles. Under this activity, we basically working on the 3 major programs. One is called PSLV, Polar Satellite Launch Vehicle. Second is called GSLV, Geostationary Satellite Launch Vehicle. Then RLV, it's a reusable launch vehicle. So this sector is basically focusing on the development of technologies or science on related to the space transportations. We have the another group which is working on the space infrastructure. Basically, they are developing the space assets of the country. So when I say the space asset, they are basically different type of satellites, and these satellites are remote sensing satellite, or we call it as a Earth observation satellite. Then we have the communication satellite, we have the navigation satellite, and also we have the planetary science missions like Chandrayaan-1, Chandrayaan-2, Mars Orbiter Mission, AstroSat, and so on. So these are the basically space infrastructure group. And then we have the space application. Under the space applications, we have the group team of scientists and engineers. Those are trying to understand or utilize these technologies for different applications, and these applications include the Earth observation applications, communication applications, navigation applications, and so on. And our another group is working on this human space flight program. This is a new activity what ISRO has started. You must have heard about the mission like Gaganyaan. Under this activity, we are trying to build our capability to send the humans in the space and to do the scientific experiment in the space. And this particular activity is very, very important activity for ISRO, and there is more emphasis is given, more attention is given by our team here. So very soon you will be seeing some good development here, like Gaganyaan program, which is in pipeline. So the work is going on in very serious way, and we are trying to build our indigenous capability in this domain. We have a very strong group working on the capacity building, basically with respect to capacity, that is in-house capacity, capacity in the country, provide the training and education activities and so on, where our focus is on developing the technology and science on the people-centric and application-oriented solutions by using the space-based data products and information services. To execute all these activities, so majorly 3 important organizations called ISRO, New Space India Limited, or we call it the NSIL, or in space. are basically working together to provide the people-centric application in the country. So if you see the major programs, we have the INSAT series of satellite, GSAT series of satellite. These are basically used for communications and weather services, and these are most of the time are orbiting in geostationary orbit, which is located around 36,000 kilometers from our surface. And we have a good series of satellite here, good infrastructure is available. Second class of satellites, what we have is Indian remote sensing satellite, or we call it a IIRS satellite. Under this program, basically we have the satellite like Cartosat satellites, which are used for the cartographic applications. We have the satellite called Resources satellite, like Resources 1, Resources 2. These satellites are used for natural resource mapping, disaster management, disaster monitoring activities, and so on. These satellites are basically orbiting in the polar orbit, or also known as a Earth observation satellite. Then we have the Global Navigation Satellite System, or we call it a GNSS satellite. Here two major programs are available in the country. One is called Navigation with Indian Constellation, or we call it a Navik satellite, and second is a Gagan. So Gagan is basically a GPS based system which is used for we call it a geo-augmented system, and it is used for improving the accuracy of GPS signal. You may be knowing that GPS is a service hosted by United States of America, but in India we have our own navigation satellites called Navik, and these satellites are also known as a IRNSS, or we call it Indian Regional Navigation Satellite System. So under this activity right now 7 satellites are in orbit. They are basically used for getting the navigation services, and if you try to compare these navigation services with similar service is GPS from US. So Navik is a Indian constellation basically designed as a regional service which is giving services within 1500 kilometers of our own borders. Then we have the planetary science missions. Under this activity we are basically trying to learn or do the research in the planetary experiments, like we have the lunar mission called the Chandrayaan 1 and Chandrayaan 2. We have the Mars orbiter mission and Astrosat. In very soon, maybe in the month of July or August, sometime we'll be launching another planetary mission called Chandrayaan 3. The work is going on very seriously in this particular program. Dates are not yet announced. The Gaganyaan part already I discussed about it. This is called human space flight programs. To execute all these programs, we have two type of launches which are operationally available today. It's called Polar Satellite Launch Vehicle, or called PSLV, which is used for launching the remote sensing satellite, typically the Earth observation satellite. Then we have another launcher called Geostationary Satellite Launch Vehicle, or we call it a GSLV, for launching the INSAT or GSAT series of satellite. The INSAT series and GSAT series of satellites are used for communication and weather services. As per the current Indian space assets are concerned, we have a good constellation of satellite in the orbit, like a communication satellite, navigation satellite, Earth observation satellite, and so on. This is just examples. Like we have this is a little bit old slide. Around 114 space missions are completed, 84 launch missions completed, 13 student satellite, and we have the 2 re-entry missions, and around 342 foreign satellites are launched by ISRO. So for latest information or latest numbers, I request all of you to please visit the website of ISRO. So we have the latest updates there. So you can see a very good space infrastructure is available, and the important mandate of ISRO is to set up the space infrastructure for the country. So where we are very seriously working on this part. Now slowly we are inviting the private organizations also to join this initiative and set up a good space infrastructure for the country, so that we can use these technologies and this satellite for different type of applications for betterment of our society, or to solve the many problems related to our society, either it's a scientific problems or any thematic problems. If you talk about the Indian Earth Observation Program, which is one of the very vibrant programs, we have a good number of satellites here. We have the capability of land and water resource mapping, high resolution satellites like a Cartosat 1, 2 and 3, which are used for cartographic applications. We have the satellite called OceanSat satellite or Saral Altica missions, which are basically used for the oceanic applications. For weather and climate, we have the very good satellite called INSAT 3D and INSAT 3DR, which are used for taking the cloud cover, cloud density, cloud fractions, and they are used for the meteorological applications like forecast, weather forecasting, and so on. So there are many applications right from the mapping to forecast. You can use this satellite data for these applications. During this course, we'll be discussing more about the application of this satellite, and maybe some other speaker will come where we'll be discussing about how these satellite data are used for different governance applications. It's not only the thematic here. In the government sectors, we are directly using these data for different type of applications which are directly used for the civilian services and so on. Now let us try to understand the activities of different ISRO centers. So as you can see in this map, we have a pan-India coverage. You can from the north to south to west to east, everywhere there is a presence of ISRO, and these ISRO centers are involved in different activities of the space program. Some of the centers, as I told you, are involved in the launch vehicles, developing the satellites, developing the payloads, sensors, applications, training, education, capacity building, space observations, and so on. So let us try to understand what these centers are doing. So I will start from the Bikram Sarabhai Space Center, BSSC. It is located at Thiruvananthapuram in Kerala, and this particular center is a dedicated center for launch vehicle activities. They develop innovative technologies, they do the research, and they also develop the launchers for the Indian space programs. As I told you, the PSLV and GSLV, these are the two major programs which are operationally available today for different type of activities. If you take the example of PSLV, this is basically for launching the remote sensing or earth observation satellite, and for communication and weather satellite we use the GSLV. But here the capability of the launchers are very, very important. Today the best capability what India is having is we can launch the 4-ton satellite in geostationary orbit, that is around 36,000 kilometer from Earth's surface, using our GSLV Mark III launcher. Then these are the few more visuals. This is a visual for developing the reusable launch vehicles from the BSSC. This is another R&D project what our team is working on, that how we can use or reuse the space launchers basically for different missions in multiple times, basically to reduce the cost of the any space mission. Then we have the another center called U.R. Rao Space Center, or we call it the URSA. This particular center is located in Bangalore. In Bangalore, this center is dedicated for basically integration of the satellite. They build the satellite in Bangalore. Either it is a Earth observation satellite, or navigation satellite, communication satellite, or maybe planetary mission satellites. So basically they are building the satellite, integrating the satellite in the Bangalore, and this center is one of the very, very important centers. After building this satellite, they are transporting this satellite to our launch pad in Sriharikota. That I will come in later stage how they will do it. Then we have the Satish Dhawan Space Center, Sriharikota. It is in Andhra Pradesh. So you can see these visuals are from the control room. You can see the building of this control room, and also the inside view also is shown here. This particular center is responsible for launching the satellite. Either this is any type of satellite. We have the two launch pad there, launch pad 1 and 2, both are operational today, and right now we use these launch pad for launching our own space missions. But recently government has also opened availability of this launch pad for the private vendors or companies, they can also come there, they can build their rocket, they can build their satellite, and they can use these launch pad for their own space programs or space missions. So this is a very, very important center. Either we build the rocket or satellite, ultimately all these things has to be transported to the Sriharikota. So it is a coastal area, it's a small island, so transportation through sea is very easy here. So that's why this particular area is selected, and very important area basically to execute the space program or space mission in the country. So these are another visuals. You can see how the rockets are transported to the launch pad before it's launching. You can see here the first launch pad, we call it the FLP, and the second visual is for the second launch pad, we also call as a SLP. Now liquid propulsion system center, or we call it a LPSC. So we have right now two centers under the LPSC. One center is located in Bangalore, second is center is in the Balyamala in Kerala. So this center is responsible to build the technologies for liquid propulsions. So basically fuel for the satellite launch pad, so for the rocket. So they are building the fuel, and they are specialized in the liquid fuel. In the liquid fuel, the benefit is they have a lot of facility, like they can control it as per the requirement. So this center is dedicatedly working on this particular technology called propulsion system for the rockets. Another important center called IPRC. This is called ISRO Propulsion Complex. So what we are doing here, we are basically, it's a testing facility of the different type of rocketry components. Like it is equipped with the state-of-art facilities necessary to realize the cutting-edge propulsion technologies product for Indian space programs. And we have the testing facility for the cryogenic stage and semi-cryogenic stage also in this center. This is near Kanyakumari. It is basically called a place called Mahendri, where this particular complex is available today. So basically for testing purpose, we test or we do a lot of experiment here before launching or before using this propulsion for the operational purpose. So in the IPRC, you can see here in this we have the ground testing of earth storable propellant stage, cryogenic stage for the launch vehicles. We have the high altitude testing of upper stage engines and space thrusters, and we have the testing subsystems propulsions, supply of cryogenic propellant for the Indian cryogenic rocket programs, and we also have a semi-cryogenic cold flow test facility. We call it a SCFT, which is established in the IPRC. It's a good infrastructure available there. So lot of experiment, lot of testing activities are happening in this particular place. The Space Application Center is located in Ahmedabad. This is one of the important center of ISRO. Basically in this center we develop payloads and sensor for satellite of ISRO. When I say the payloads, basically these payloads are brain of the satellite. Either you use the communication satellite, weather satellite, or you develop the remote sensing satellite. So we develop the sensors also in these centers. So you may be knowing about the different type of sensors of ISRO, like we have the Cartosat, we have the LIS-3, LIS-4, we have the ABIBS, and so on. So it's a very, very important center. They are developing the brains, and once the payloads and sensors are ready, they are basically transported to the URSC, where they are integrated with the satellite before its launch through Sriharikota in our launch pad. So these are some of the examples. These are the outcomes of these satellite sensors. You can see like ocean science, geological applications, agricultures, and disaster management, disaster monitoring, geological applications. There are so many applications of these sensors. This is one of the example how these sensors are giving output for the our own applications. Then we have the another unit. Recently it is merged with the Space Application Center. It was a development and educational communication unit at Ahmedabad. We call it a DECU. They are the basically a small group. Now it's not no more the unit. They are the small group now under the Space Application Center. They are basically developing the did lot of educational contents, basically on the use of space technology, use of satellite data, and its application. They also have the telemedicine and teleeducation activities they are supporting through this particular group. ISRO telemetry tracking and command, that is called ISTRAC. This particular center again, it is basically available in Bangalore and also in Bailulu. So they are basically using for tracking the satellite. Through ISTRAC we do the tracking of the satellite. They have their data center or this is space data center in Bailulu also near Bangalore, which are basically used for tracking purpose of the most of the time they use the tracking of the planetary missions and also tracking of the remote sensing satellite. But we have the master control facility which is basically in Hassan, but they have the center in Bhopal as well and also in Lucknow. They are the master control facility, or MCF is basically for tracking the communication satellite and weather satellite. So they are basically doing the health monitoring of the satellite. If there is any issue or any technical glitch, they are repairing these things through the command based systems, and this facility is very, very important, and we have the different places their presence is there for the communication and weather satellite. ISRO Inertial System Unit, ISU, it is a small unit in Thiruvananthapuram again. They conduct the research and development in inertial sensors and systems and allied satellite elements. So basically they are building the sensor systems for the satellite. So whatever, if you take the example of the smart solutions or intelligent systems or brain, basically these sensors are developed under this unit called ISU. Then we have the laboratory for electro-optic system. They specialize in, again they are located in Bangalore. They are engaged in designing and development of and production of electro-optical sensors and camera optics for satellites and launch vehicles. So they build these camera optics for launchers as well as the satellite, and the sensors include like star trackers, earth sensors, sun sensors, and processing electronics and so on. They also have a very strong group working on this battery system for these satellite sensors. We have another important center called National Remote Sensing Center, we call it the NRSC, which is located in Hyderabad. This center is basically having two important activities. One is data reception from the remote sensing satellite. For this we have a ground station in Satnagar, which is nearby Hyderabad, around 60 kilometers from Hyderabad. Here under this Satnagar we have the big data centers. We are receiving the satellite data not only from Indian space program, but also some of the data from the foreign satellites are also we are receiving there, and we are processing this data. And in Balanagar in Hyderabad we have the application group, how this satellite data can be used, can be applied for different thematic applications, and this particular group is working to provide the technical support to different central ministries, government ministries and state government departments for utilization of the space-based data products and information services for different thematic applications, which include disaster monitoring, disaster management, and so on. So two activities, one is data reception and archival of the data under data center called IMGOs. Second part is application of this data in the governance and development in the country. So this center is located in Hyderabad. And although the NRSC is also having their presence in different part of the country through the regional centers, we have the regional center in Delhi, we have the regional center in Bangalore, in Nagpur, we have the regional center in the Kolkata. So region wise, these services and supports are provided to the government user departments and ministries. NRSC also is having a very strong unit for the aerial services and digital mapping. Right now they also have their own aircraft. They can fly, they can basically capture the high resolution imageries for any part of the country. And now they are setting up or establishing the drone based mapping services in Hyderabad as a national drone facility and so on. Indian Institute of Remote Sensing, or we call it the IIRS Dehradun, from where we are conducting this program. I am sitting here in this center. This is also one of the very important unit of ISRO, basically on the training, education and research in the area of remote sensing technology and its applications. We are conducting the on-campus training programs and also online training and training programs on different topic of remote sensing technology and its applications. And today's this training programs, what we are conducting for the school teacher, is one of the activity under the activities of IIRS. Recently, IIRS has also started a program for the space science and technology for the school students under the Antriksh Jigyasa programs. I invite all of you, all the teachers, to please visit our website called jigyasa.irs.gov.in, where we have developed a lot of innovative learning content for the school students, class 9th onward, what we are targeting there. So these contents are available as a small video contents and also as a PDF for the learning purpose, for studying purpose. And we also have many courses for the student. They can simply join these courses through Antriksh Jigyasa. And under these things, we also have provided a virtual platform for the students, so they can, if they have interest in the space science and technology, they can submit their ideas, their solution to the ISRO scientists. We'll evaluate these ideas and solutions. If any good entries are there, we are basically acknowledging and recognizing these students in appropriate forums. Under these platforms, the application for ISRO Yuvika programs and so on are open, and it's a very important platform. Since you all are teachers, I invite all of you to visit this website called Antriksh Jigyasa, where you'll be getting a lot of learning content for your students. IIRS is basically, as I told you, we are focusing training, research and educations. We are one of the center of educational institution of excellence as per the Parliament Act 2006. Although our main focus is on the remote sensing and GIS, but we also conduct the training program for on space science, technology and its applications. So there are many activities in our centers. We have the training programs, we have the education programs, we have the research programs and outreach activities, which are listed here. As per the training is concerned, we have the PG diploma programs, certificate courses for teachers, especially for university professors. We have an anonymous programs. We have the program for decision makers, planners and decision makers. We have the program for the international users under the Ministry of External Affairs. We also host a center under United Nations called Center for Space Science, Technology and Education in Asia Pacific and so on. Then we have the education program, MTech, MSc and PG diploma programs, research activities and the Department of Space funded projects, user projects. We also have the technology development programs in the centers here. Under the outreach activities, we have the distance learning programs. Basically, we conduct many online training programs for the different type of users, and the school teacher is one of the type of course what we used to conduct here. But we have a very good training calendars what we publish every year. I invite all of you, please visit our website iirs.gov.in and look for the possible course for you, and you can join these courses either in online mode or in offline mode. As I told you, we are also hosting a center called CSSTAP, which is a UN affiliated center, and under this center we are providing this training education for the participant of Asia Pacific countries. They are coming to our center and they are taking these training programs. Either it's a long duration training programs on PG diploma programs or short duration programs. So here we conduct the programs on remote sensing, NGIS, space weather and their meteorological applications and small satellite programs and so on. So basically through different ISRO centers we are conducting. So you can visit the website of CSTAP also and you will get better idea about the activities of this CSTAP. Under the online training programs, we have the live and interactive classrooms and online e-learning programs. Already I discussed about it. So these are the some important things what IIRS is doing. Under this Antriksh Jigyasa, already I discussed about it. E-class portal already you are using for this particular training programs. We have the international training program in virtual mode called ISET portal. This is a ISRO IIRS space application training programs. For the international users, we are conducting online training in collaboration with the different international institutions. Now come to the physical research laboratory, or we call it the PRL. As you can now understand that the birth of ISRO happens from this particular lab. So they are doing the research on the planetary experiment science. In the planetary science, they have the very interesting groups there. A lot of research activities are happening there. They also provide different scientific input to ISRO for their planetary missions. PRL is also having their solar observatory in Udaipur, and this is one of the beautiful infrastructure what India is having. So this observatory is basically maintained and operated by PRL Ahmedabad. National Atmospheric Research Laboratory Tirupati near Gadanki, they are basically there. They are doing the research on atmospheric science, and by using the space-based data and observations, and their research is used for many space missions of ISRO, basically to understand the atmosphere and its behavior. Indian Institute of Space Science and Technology, we call it the IIST. This is again located in Thiruvananthapuram, Kerala. Here what we do, this is a educational unit of ISRO. Under this institute, we are conducting the undergraduate programs, postgraduate programs and PhD programs basically for the students. And these programs, some of these students or some of the engineers from this institute are joining the Indian space program also. But generally it is open for any student. They can join and they can undergo these courses like a BTech programs, MTech programs and PhD program through IST. Northeastern Space Application Center is a dedicated center set up by ISRO in Shillong, basically to provide the technologies or technical solution on using the space data, space-based services for Northeastern region. And they are basically working on the Earth observation, satellite communication and navigation, and also drone-based remote sensing observations for Northeastern states. They are dedicated center basically for Northeastern states. Antarish Corporation Limited, this is another commercial unit of ISRO. They are basically providing the commercial solutions for the different national and international users. And this is a new entry called New Space India Limited, or NSIL. Already I discussed about it. Again, it's a commercial unit of ISRO. HSFC, already I told you, this is Human Space Flight Center. Again, it is located in Bangalore. This center is working on developing the technologies on the human space flight programs. Under these programs right now, the major program which is running on is called Gaganyaan program. So this center is basically working on this area of the human space flight program. So if you see the milestones, I will not read. These things are available in our website. The journey was started from 1962 on 16th February when the establishment of INCOSPAR what happens. Slowly in 1963 in the November, again the first rocket was built. Then slowly you can see there are many missions, and here now the Gaganyaan program, which is a new entry or latest research areas where ISRO is working very seriously. It's one of the very important and ambitious program for ISRO where currently we are working on it. So I request all of you, please visit our website, keep on watching the updates what ISRO is publishing. We have our social media handles in the Twitters, in Facebook, or all the updates we are publishing there. We are conducting many online training programs, in campus training programs, awareness programs, workshop, conferences, and so on. So please motivate your student to join this space activity in the country so that they can be a future asset, a future scientist of the country. With that, thank you very much. Now I invite all of you for your questions, although this particular session was not too technical session. It was just a introductory session. Tomorrow Director BSSC, Dr. Unnikrishnan Nayarji will be continuing this session with little bit more details about the different missions, activities and their application as well. With that, thank you very much. Thank you for joining this